Hello guys, we have a question here to solve and I read the question. Prove that the integral 1 over pi integral from negative pi to pi x squared sine nx dx is equals to 0, where n is a positive whole number. And so guys, we start off doing the question. So guys, here is the question. As you can see, I have put a bn here. Since I am doing this for Fourier series, but guys, let's now look at the integration by parts. So don't mind about the bn, it's just used because we shall use it in the Fourier series. So what we are integrating is this, that is 1 over pi and integral from negative pi to pi x squared sine nx dx. So we use integration by parts. We say this is u is equals to x squared, du is equals to 2x dx, then we have dv equals to that, then v comes to that. And so we use this equation. Guys, we don't have to put this, we just go direct to u and v. And for that, we have our u here, this is u. As you can see here, we have u equals to x squared. And this negative is from this v, is from v. Negative cos nx all over n. Now minus, we have v is negative cos nx all over n, and then du, we have 2x and dx, and this is 2x, and then the dx is right here. From there, guys, we now come and now we need to integrate this. But before that, this negative and negative will form a plus. And so integrating this, we still do integration by parts yet again. This we have completed with it, and now we are doing this. We still use the same format as we have seen. This is, we have u equals to 2x. This is only that I wrote x first, but it's supposed to be 2x. And this is now the derivative for 2x is 2. Here we have dv equals to that, v will now come to that. Now we just need to replace, and in the replacing, we don't have to write the equation again. We just come and write this is u now, and which is 2x. This is actually 2x. The 2 should be here in front. And this is the v minus integral of du, which is 2. We have a dx right there. This dx is the one that is here. Then we have sine nx all over n squared. And from there, now our equation is right here. So we have this equation. And for that, guys, for this, it is going to be 0. And the reason is that if you put n, any number here, and then you put pi, because our limits are negative pi and pi, either you put pi or negative pi, guys, this will come now to 0. And so this is cancelled. We are left with these two terms now. And so here there are terms that have been left now. This is now, as you can see, the sine one has been eliminated. We are left with the x squared cos nx all over n, and then this. And then from there, guys, we're now going to do that. We factor out the n. We are left here with 1 and here with the n squared. And this is the step. From there, we fix the values now, which is pi and negative pi. So we have here, we start with the pi. Remember, the negative was initially there. So so this is pi squared, n pi plus 2 cos n pi, n squared minus, we had a minus here. This is the minus that is always there when you are looking at the difference between the upper and the lower limit. The minus is always there. And then we have minus here. This minus is this minus, as you can see here. So our x now is negative pi. So this is minus again from negative pi, the lower limit, then squared. Cos n pi, as I said, cos n pi and cos minus n pi is the same. Now plus 2 cos n pi all over pi squared. N squared, this n was initially there. And so with that, guys, this is what now remains. So all this is going to be plus. This now becomes plus. Because there is already plus there, and minus gives us the plus. And when you do that, guys, you will find that this value and this will cancel. This and that will cancel. And so, guys, our solution will then be that. And so, thank you, guys, for listening to me. Bye.